All right, let's go ahead and try to solve this problem. So we have Bob currently has $10,000 in the savings account and he wants to prepare for his retirement. So he's going to start next month by depositing $300 each month into his account for the next 30 years. And that's 360 months. The account is going to pay interest, APR of 6% per year. And we want to know how much is he going to have at retirement. So after 30 years, how much is going to be sitting inside his account. All right, so we can draw a timeline just to visualize how this is going to look. So today he has $10,000 already in his account. So I drew this timeline. Here's time 0. He'll have $10,000 in his account today. And then in the future, he's going to deposit $300 each month for the next 360 months. So I'll put those on the timeline here. So he's going to get $300, deposit $300 that month, this month, and every single month until month 360. All right, so we can look at this problem as two separate problems. So we have problem, I'll call this problem A, is we want to find out what will this $10,000 grow to at the end of the 30 years. So problem A, what will the $10,000 grow to? All right, so that's problem A. Problem B is I can look at the deposits that he's making. So we have these deposits. So problem B, what will the $300 deposits grow to? All right, and so so we can look at these as two separate problems. So for part A, what will the $10,000 grow to? Well, that's just a simple future value. So we have $10,000 today, earning interest. What will it grow to by 360 months? All right, so I can use a formula. So I'll do that first. So to solve this, we would say it's equal to the future value, how much we're going to have in the future, is equal to the present value, what we have today, times 1 plus the interest rate raised to the n power. All right, so our PV will be $10,000. That's how much we have today. Our interest rate is going to be the APR. So we have a 6% interest rate per year. But because this is a monthly problem, so we're getting interest every single month, we're going to have to divide it by 12. So this will be 0.5% per month. And then for N is how long we're going to be investing. So this is going to be 30 years, but we're getting interest every month. So 30 years times 12 will be 360 months. All right, so if I put this in here, so we have $10,000 times 1 plus 6% over 12, which is that 0.5 that we have here, raised to the 30 times 12, which is the 360 that we have there. What I end up getting is 60,225. So that answers our first question. So if we put $10,000 into the account today and let it sit there for 30 years, what we're going to have at the end of the 30 years is 60,225. Now, the second part is alongside that $10,000 that we're going to have in the account today, we're also going to deposit $300 every month for the next 30 years. So that is a perpetuity. So, an annuity. An annuity is just a regular cash flow that comes at a regular frequency, that it doesn't change. So figuring out the future value of the annuity parts, the future value of the deposits, there's another formula that we have. It's a little more complicated. This is equal to the payment size times 1 plus the interest rate raised to the n power minus 1 divided by the interest rate. All right, and the variables are going to stay the same for I and n, just as we had before up here. but our payment is the $300. So we'll make these $300 deposits times 1 plus the interest rate. So 1 plus the 6% over 12. And then raised to the 30 times 12. So that 360 that we have there. Minus 1 divided by 6% over 12. I'll rewrite it so it's a little more clear. So 300 times 1 plus 1.005 raised to 360 minus 1 over 0.5%. So working this out, I get this to be 301,354. So 301,354 is the value that's going to be in the account due to the $300 deposits. So the last thing we have to do is notice that we have the value of there are two different components. So we have part A, what's the value of the $10,000? What's that going to grow to at the end of 30 years? So we get 60,225. That's part A. And in the second part, we have the $300 deposits. What are those going to grow to at the end of 30 years? And we get 301,354. So we can do the last part, and we'll say part C. What's the total? How much are we going to have in total at the end of 30 years? Well, it's just going to be these two parts added together. So this is going to be the 60,225, which remember that's what the $10,000 that we have to begin with is going to grow to at the end of 30 years. And then we have the 301,354. That's the value that the $300 deposit is going to grow to at the end of 30 years. So adding these together, I get 361,580. And that's our answer. So if we want to know how much Bob is going to have in his account once he retires, well, he's going to have a total of 361,580. We just did this problem by hand. We can also use Excel to solve this problem out. So let me go to Excel and let's work that out. So we can break it up into those two pieces like we just did. So what will the $10,000 grow to after 30 years? Well, we're just looking at that $10,000 part, so we can input our same numbers that we had here for N, I, that we had before. So our N was 360 months, and our I was 0.5% per month. So I'll go to Excel and put those in. So my N was 360 months. I was 0.5%. Our PV will be $10,000. I'll make it a negative because Bob is going to be depositing $10,000 into his account. So put that in there for negative 10,000. And then our payment is going to be 0. Since we're just looking at the $10,000 by itself, we're just saying put $10,000 into the account today. What will that grow to after 30 years? All right, and so what I want to find out is future value. So I'll say equals future value. My interest rate is I. NPER, number of periods I'm investing, is 360 months. My payment is going to be 0. My PV is this negative 10,000. And then we'll make this period 0. All right, and I get 60,225. And you'll notice it's the same thing that we had here when we did it by hand. And then next we have to tackle the second part. So our second part was part B. What will the $300 deposits grow to at the end of 30 years? All right, so we'll work that out here. All right, so our inputs are the same for N and I. So we're still getting 360 deposits. Our I is still 0.5% per month, so that's 0.005. In this case, our PV will be 0 because we're just looking at the $300 deposits. So we're not starting out with anything. At time 0 for this part of the problem, we have nothing. But for payment, we have the $300 monthly deposits. So I'll put negative 300 because $300 is coming out of Bob's pocket every month for the next 360 months. All right, and then again, I'll solve for FV, for future value. So FV equals my interest rate. Number of periods is 360 months. My payment is the $300, negative 300 that we have there. Our PV is 0. And then type, we'll say it's end of period, so I'll put in a 0 there. And we get 301, 354. So that should look pretty familiar. We have the 301, 354 right there. And then to finalize it, we can just add it together. So our total is going to be this $60,225 that we have for Part A, plus the 301, 354 that we have for Part B. And so our total is 361,580, just like we had here when we did it by hand. Lastly, we can do it all in one step. So we broke this up into 2 parts, so Part A and Part B. We can actually do it all in one step. So let me just do that here. So we'll have the same variables that we started with. So we had 360 is our N, so we're investing for a total of 360 months. Our I will be the 5.5%, so 0.05%, 0.005. We can say our PV, what we have today, what we're starting with, is $10,000. So negative 10,000, I'll put in here for PV. And then we can also, at the same time, put in our payment. So negative 300 was our monthly payment. So instead of doing them separately, so on this one, I didn't put any payment. For Part A, I didn't put any payment. For this one, for Part B, I didn't put any PV. But if I do it all together in one step, I'll put in the PV and the payment at the same time. And then I'll just solve for future value like I've done before. So my rate is this 0.5%. My N is 360. Payment is the negative 300. PV is negative 10,000. And I'll make type equal to 0. And we get 361,580, which is the same as the total when we add them together. All right, so yeah, that's one way you can do it all in one step without breaking it up into components. So if we wanted to find out how much will Bob have in his account when he retires in 30 years, well, it's going to be the 361,580.